Hi, this is just a quick video to cover actually the Sweep2 command, which I find personally very useful in terms of basically kind of mocking out sometimes curved geometry that has the very specific, let's say, cross sections with a certain level of precision, but getting things to kind of flow with each other. And so uh, having good control over both like the sort of ends and the sides of a surface, but then having good control over what the cross section looks like, essentially. Okay, and this is kind of one of the most useful commands for doing that. Uh, so to start out, right, this is the file that I'll give you guys and host it on Canvas. It's very simple. Just one side is straight line, the other side is a control point curve. And to start, right, I'll actually just kind of draw two of these lines, okay? And the one on the front here, I will just rebuild. So use the rebuild command to something like this, a point count of 5, degree curve 3, okay? And you'll see that I get basically more control points, right? And you can highlight it, right? Usually I do a sort of odd number just because then I can select, right? Or you can come here, turn on the control points by clicking on F10 and grabbing them individually, right? This is sort of a quick and dirty way for me just to kind of like, get, let's say, cross sections. And actually, we should do both of these together. So move, let's say that. So it's a sort of almost like an arc or a parabola, right? This one I'll leave flat for now, just we can kind of see what's happening with the options. So if I run Sweep2, first rail, okay, so this one, second rail, this one, right? Cross-section curve, so first cross-section curve, second cross-section curve, and then enter, right? So you'll see, just kind of zoom in a little bit. You'll see essentially it uses this. There's a little bit of, let's say, bold or scaling because it's also kind of using the width or the distance between rails to kind of scale the section up and down. And so it takes that and basically kind of interpolates it to, let's say, this sort of end section curve, right? So that's what you would get in this situation. Now there are a couple options. For example, one to kind of look at is like the maintain height, right? So maintain height essentially uses whatever your sort of cross-section curves as information and pretty much tries to stick with that, right? It doesn't scale in the height using this sort of width or distance between the two curves, okay? So that's just something to toggle. We'll look at those maybe a little bit later, okay? So for example, if you do that, okay, we can kind of, take those and copy them off to the side. Whoops. Delete. Okay. Let's say what happens if I delete that, okay, and then you do the Sweep2 command, 1, 2, 3. So you'll see that because I didn't explicitly define, right, that end to be completely flat, what happens is that like it basically assumes the same profile but just scales it, right, and it fits it in to end that profile. It just uses 1 instead. All right, so that's another one. Okay, let's say I add this back, and I want to do a different, let's say, section, and sometimes I'll use this. Essentially, these profiles, this and this, these profiles, you can actually do as many as you want, right? As long as their ends actually touch the two rails, okay? And so to do this, I'll usually turn on my near snap, right? And let's say click somewhere, and you can click to near or try to do something more perpendicular to the direction of the line, right? And I'll do the same thing. I'll rebuild to a 5-point curve and do this, right? So this one, because I'm only pulling the center, right? The ends kind of flatten or taper out, right? Which is different from here. So let's see what we'll get. Sweep2, first rail, second rail, and then 1, 2, 3 in sequence, okay? So you also will see that the sort of isocurve directions start to slant, right, based on how you arrange your profile curves. And that will actually have a difference or have an effect on how the geometry and the curvature is interpolated, okay? So you can also use this to basically kind of force, right, parts high or force certain parts lower. Um, in these cases, let's say if you rebuild the cross sections, and because I was actually using curves with 5 control points in the first place, it's not going to be like the biggest difference. But if you kind of change that parameter, then you'll see the output gets either more complicated or more looser, right? This usually isn't necessary unless your cross sections, like some of your cross sections are really complicated, and we'll actually kind of get to that. Basically, one of the principles you'll want to stick to is to kind of keep your cross sections, let's say the density or the complexity of your cross-section curves pretty much similar or the same, right? To get pretty much a cleaner, let's say, sweep, like that. Okay. Now, on the other hand, like let's say even without this, okay, built into the Sweep2 command, you can actually, if we do the simple sweep first, you'll see this sort of add slash option, right? Which I can use, and I can use to control. And let's say because these are kind of going perpendicular, so let's say if I do click here and here, right, you'll see that it starts to kind of adjust the directionality of these. So make that wider, right? And this is a way to actually control let's say the width and the spacing, right, of the profile curves that the Sweep2 command is using, right? So this is actually built in, and it's helpful for these sorts of situations, right? So move that over. All right. Another kind of scenario or situation you can kind of look at is something like this. We'll kind of do this essentially where one rail is smooth, the other rail is more like a polygon or a polyline curve, right? Let's do the same thing here, rebuild, and I'll move the center point up again, as well as these side points to do that. Okay, so Sweep2. Okay, so you'll see that it actually deals pretty well with transitioning, between, this sort of kinked geometry. You'll see maybe that might happen, right? Maintain height sometimes will help fix that, right? Because it just kind of, slopes it down. But actually in these situations, I think actually the add slash really comes in to help, because you can kind of control where or how the geometry really wants to kink. In this, actually, sometimes what you would do is actually just add another profile there, so you can kind of control the sweep a bit more, directly. So add a line. All right, and depending on if you wanted to go up or down, then you can always add more cross sections to control the end result. So we'll redo that. Still a little bit of a bulge. Okay. Right. So you'll see kind of a little bit more of the segmenting here, and if you kind of go into rendered view or something like that, right, because there's that kink, it eventually kind of has to smooth out. It will actually smooth out by the time it hits this side, essentially. So that's why that sort of divot is there, because it's most prominent here and eventually kind of disappears towards the back, right? Another example is, let's say this, where both are sort of polygonal. And we can do this. Now, if you wanted to, you could also like do even more, right? Actually add, explicitly, things or cross sections at the ends here as well. But I'm actually gonna not do that. I'm just gonna rebuild these two. And I think I'm not going to show all the different sort of permutations of this, but you can kind of imagine or play with the sort of different combinations that this might, allow you to explore. Okay, sweep. Right, so this is a kind of more segmented version of it, right? And same thing with the adding slash, you can actually kind of control the way that geometry gets resolved, for example, right? And this one in particular is a way, because you'll see obviously the geometry kind of has to like sweep these two segments, kink, right? Basically kind of make a hard turn here, a hard turn there. So this actually is the point where, like, if you make slashes in the right directions, right, then this is the part where it's actually kind of able to absorb that sort of like extra segment, right? So because this rail is 1, 2, 3, 4, that rail is 1, 2, 3, right? So there's an extra segment here that has to be kind of absorbed somehow, right? So this gives you kind of that kind of result. All right. Actually, one more thing to try here is to see, for example, if I actually just did, let's say, a line from here to here, right? And instead of actually it being a smooth curve, I made it, let's say, a polyline. All right. So in this case, I'll just use the divide command and split it into 3 segments like this, and split set to yes, right? Which will split into three individual lines, right? I'll join it back again, turn on the edit points by clicking on my F10. So I'll get these edit points. Let's do that, right? So that's a kinked polyline. So let's see what happens. 1, 2, 3, 4, 5. Okay. Let's see. So what happens is, right, you'll get that kink, which is that transition, and it also starts to transition over here into this more faceted version as well, right? Actually, I'm gonna copy this one over because I want to do it on the smooth side, right? So in this case, that leg is actually already touching that curve, so I just need to move this curve and snap it to that rail, and that's where the near snap comes in really handy. Oops. And let me move this one inboard a little bit. Now you can also kind of play with this, like the sort of directionality where it is sort of in plan, right? It doesn't actually have to be, a straight line in plan either, right? Like you can, let's say if we pulled this one this way a little bit just to see what would happen, right? Okay, so sweep 2, 1, 2 rails, cross sections. Okay, right, so it does that pretty well, and then you'll kind of see like the surface actually gets sort of split apart to try to merge right into the facets. In the sort of rendered view though, right, like it's sort of probably that corner or this crease that you'll see the most, because it's basically trying to go through from complete smooth to completely faceted. One of kind of the ways to start to fix that essentially is to add another, let's say, cross section there, right? Because it will then start to blend from smooth to faceted, within this zone, and this part will be smooth. So let's rebuild and just make one of these really quick. Okay. Maybe pull it down a bit. Okay. Sweep 2, 1, 2, 3, 4, 5. Okay. So you see this is smooth, right? That transition, even though it's been split into 3 surfaces, to kind of deal with the fact that it eventually gets faceted, right? And it only starts to show the creases here towards the back, right, where it's starting to meet that edge. Okay. Yeah, and this is a pretty powerful, let's say, command to do a whole wide variety of things. This is kind of only the beginning of it, and this is kind of assuming that all the sides are plans, for example. But you could also just as easily say, okay, I want to pull some of these corners up, right? In a situation where, let's say maybe this might be the entrance to, a building or a project that you're kind of working on. Right? So you can kind of actually use this ability to sort of conform to multiple geometries that way. That one's a little bit messier. As well, actually, let me actually copy this out. And we'll take all these guys and just copy one over. For example, you can actually close these as well. So if I use the connect command and just like collect these guys, right? This we don't need, for example. I can actually sweep this with just those two rails and end, and it will basically kind of like taper down to that point as well, right? When they connect like this. There's also, again, connecting those, right? And having a sort of middle curve there. Actually, this one should probably be in the center a little bit better. Somewhere here, okay? So I'll rebuild. Actually, I'm going to rebuild this to something like 9. Okay. And I'm going to do something a little bit different here. So we'll go up, holding down the shift key to multi-select, down, and then these last two. Right, so for example, if you actually do something that's a bit more articulated like that, right, it's also able to do it. Okay, sweep 2, select first rail, second rail, and then because there's no cross-section on these two ends, we'll just use the point. And then middle one is the curve that we made, and then again last one is a point at the end, and it will actually basically kind of sweep that profile along the length of whatever you have specified, which is pretty cool. You can make some really interesting sort of more organic section profiles that way. Okay, I think that's just kind of a little bit of a first touch of like what this can do. Obviously, you can try to apply to many situations, like thinking about facades or things like that. This is just showing you the principles as a larger kind of shape. If you kind of look at the official, let's say, Rhino information site, they have some kind of smaller examples that show how certain things behave, all these sort of different options, adding sashes, refitting the rails, maintain height, things like that. You can watch these little videos. These tips are actually pretty helpful, particularly, right, make the degree and structure of rail curves match each other, meaning these generally work better if they're similar enough in terms of how many control points they have. Obviously, you get weird exceptions when you have polylines with control point curves as the rails, because it has to negotiate these kinks, right? Turning on, let me actually do this. Turning on the, place cross-section, so endpoints on the ends of rails, so like here, right? Or on the edit points of the rails, so like there, right? And or in these cases, it's not as clear, but like on the edit points of these rails, right? Use point object snap, right, to snap them to edit points. So you can use the point, you can use the near, like I am, to basically kind of force it onto the rails. And only one section is used. The entire length of the rails use the surface, basically this guy, right, where essentially kind of use that one section curve for the entire length of it, right? Section curves can have different structures, but it will take the complexity of the most complex one, meaning that, like this, the most complex one, at least in terms of the surface, geometry, is the sort of three sides. So actually, that's what forces this one to break down into sort of three sections, right? And yeah, so this is kind of worth a quick read just to kind of understand the command a little bit better. All right, that's it.